Okay, thank you very much for the invite, and I'm here to share with you some thinking and results we have got in Munich at the European Research Center. Around 5G, and in particular, we try to understand how these emerging technologies such as network function virtualization, software-defined networking, and edge computing will really affect the way the network will work and will look like. So about the vision, and what is 5G, how is that defined? I think the vision has been defined that we are expecting a true shift in paradigm. And the shift in paradigm is to move from the client-server model, where the network infrastructure and the network itself has been reduced to a mere pipe of bits, where communication services are basically all for free, to something else that will be represented through the new concept of bearer graph. I will show you what I mean by that. That will constitute the nervous system of the digital society, the digital economy, but also the silver economy. And that means, in practice, as the European Commission attempts to achieve, is to have a new way to connect things, not only the smartphones, so that we can generate plenty of new businesses and new jobs. Now, if you look at the investment the European Commission is placing in the ICT field across the horizon 2020, which is about 80 billion of our money that we pay taxes in Europe, 12.5 billion will be placed in ICT. Now, looking into the topics and where the investigations are done, I think are mostly around closing the main challenge we are having in Europe, compared, for instance, to US, China, Asia in general. If you look at the statistics, and our professors in this room may confirm, we have the research in Europe, I think, the most advanced probably in the planet. But when it comes to the realization, which means to the real innovation, which is not just an idea, but it's a lot of money, we have a big gap. So I think what the European Commission is trying to do is to close this gap. And to close this gap, there are at least two or three main actions worth mentioning here today. So the first is to pass through the standardization. So when you research something, somehow has to go through standardization. So it's that standardized, then probably largely adopted. The other thing is the establishment of a private and public partnership. That means to support the industry, SME, institutes, by public funds, so that together we can realize really something and move from what we do in the laboratory to real applications. If you look at the initiative already ongoing, and today I will share with you the thinking around 5G, we have a lot of work done in robotics, photonics, the factory of the future, which means Industry 4.0, high computing, research, and then a lot around big data, and try also to make this data available so that plenty of applications can be developed and therefore lead to innovation. If we go now into some technical requirements and see how the 5G network will look like, I'm always repeating the same things. 5G is about three main new things. These are only three main new challenges compared to the previous network releases. So first, 5G needs to be designed for mission-critical machine communications. If you look at the new requirements we need to make or meet, achieve, targets are especially around latency, has to be dramatically reduced from 10 to 1 millisecond. But this has to be extremely reliable to connect these new objects. We have to cope also with the trillions of machine type of communications. And last but not least, we need to exploit the whole spectra, available spectra, not only on the air, but also through fiber. So that basically defines the main targets and goal of the 5th generation. If you look at how the network may look like and the corresponding services, I've tried to represent everything on this slide. And what is truly new here is basically that the infrastructure, so the ecosystem, UI, Europe, but also many initiatives across the planet are targeting, is something that will connect not only mobile phones. We have been developing networks for 20 years around cellular phones. It's now time for us to connect something else. What is this something else? Something else, as represented on these slides, are mostly things that could be physical or virtual or cyber things, but more importantly, there will be machine for mission-critical type of actions. The two main leads we are having in terms of business and services, I think, are mostly around two new strands. First, we are expecting a full immersive experience. The communication we are having today is still basically what we had in the past. So what we're expecting now is to have a three-dimensional effect without the utilization of glasses or binaural receiver. I show you how we can achieve this goal. Second, we're expecting anything as a service. So I think SDN and NFV should enable this type of model so that the network itself, I don't need to own the infrastructure, but I just need to basically purchase for a limited time period what I really need. So the network has to become as a service. Correspondingly, we are expecting to go well beyond the cloud model, the SPI model, where you have the software, you have the platform as a service. We want to go beyond this. We are expecting the data as a service, knowledge, and the machine also as a service. So that if I need a service or perform some tasks I could perform, but a machine could perform, I could simply purchase that as a service. The network, in a multi-tenant manner, should allow me to buy this service and the new operator or the new players offer those services. Another important trend also presented on these slides is where the intelligence will be mostly placed. And this is also another shifting paradigm, that as it is today, very far, I think everybody has emails, we don't know where a server is. We're expecting that most of the intelligence, computational capacity, power, networking capabilities will be located at the edge. What is the edge? By definition is anything around the end user. That's what defines the edge. So it will be around the end users where all the capability of the network will be, or most of them will be placed. And now we need to understand why. The network will be ephemeral. That means they will pop up and disappear depending on needs, and will not develop only across the infrastructure, but there will be a large degree of freedom to connect the different type of objects. If I want to talk to him or her, and there is a way to go through hopping or cars, I can do it. I don't need to go through the infrastructure back to Italy, Germany, and then routing back. No, I should be able to do it immediately, directly, so that I can meet really the performance targets. There are 5 new fundamental technologies that we realize the 5G ecosystem, and this slide represents in a high level all of them. So we are expecting sensors. Sensors that it's not just about video, audio signals, but any kind of signal that has to be captured properly and reported in real time and quasi-real time at the edge. The second important thing is about the new type of devices. So rendering, acting, or actuating will be the new type of technologies we have to cope with. So we need to connect a laser projector, any kind of projector, so that I can reproduce my experience using my smartphone, my laptop, but also in this room, in the car, at home. The fourth important new technology is about the control system in the network, so the signaling, and the way the resources in the network are orchestrated. We also have a new way of computing, and the computing will be at the edge, and then the networking I will present in a few more slides what it's all about. So how the system will work, I made this slide to present rapidly what it's all about. The intelligence in moving object, maybe cars is different because they have a lot of energy, will not be localized into the robot themselves. That's not possible because it would immediately run out of battery. And anyway, you will have a lot of energy and the performance cannot be met in terms of capability and computational power. So that means there will be a very fast connection between these robots, the elements, and the edge, and the environment also around the robot will necessarily change. So that means this element will not have our limitations, like it takes us about 20 to 25 years to become somehow independent and understand that it is a table or that is a chair. They will immediately retrieve the identity from the object and then they will find themselves in the cloud, which means at the edge where they will be virtually represented with plenty of libraries so that two things can meet. And then actions can be taken in less than 1 millisecond. That is about motion control. Now I go quickly through the different types of technologies. Full immersive experience, as I said before, can be realized by capturing and rendering signals from multiple sources. And now, this is, for example, what you have realized in Munich. If you want to have a three-dimensional experience using a full parallax holographic rendering, we would need, for each view, about 1 gigabit per second. Okay, a tenth of less than that would be the bit rate for a sound field audio reproduction. So that gives you some feeling of the speed we need to realize this type of services that the current technology and the evolution of the existing technology wireless will not meet this type of requirements. When we look at the objects we want to connect, I take an example of ICub. ICub is a humanoid developed now I think across the whole planet, but the idea is generated from the Italian Institute of Technology. I was there. I took this picture in Genova. They have 10 sites, 1,300 people. If you look at the ICub, so that basically is one of the new elements we need to integrate and connect with the network. And their requirements, apart from speed, you see it has 2 eyes, 2 cameras. We are expecting a compressed signal. And you saw this morning very nice presentation about the bandwidth we require. But more importantly is the latency. Latency for motion control. As I say, the intelligence cannot be and reside into the head of the robot. So that means you need to have a fast way. Let's see if I can, yeah, here. A fast way to report this information from there to the edge, to the cloud computing platform, and then back. Like here you have an example, computer vision. So it's just an application how the robot will scan, search, and grasp the object. And then you have a force control, which is a model of the nervous system of the robot, which return through tactile internet actions to the robot. In order to realize this, we need to stay in the order to 5 to 1 millisecond. So that gives you also an idea how large a network will be. If you calculate from the speed of the light, you can easily realize that we are maximum around 150 kilometers. So that's basically the maximum extension of the network. Okay, I could say something more about the evolution and the future of this type of elements. As today, it costs approximately, if I remember correctly, around 300,000 euros to have a massive deployment adoption of this technology as a service. I don't want to buy that to have in my house, and during the night, a robot. No, but I want to have just as a service, pay that comes, perform tasks, teaches German to my daughter that goes away. If you look at to have a large penetration of this, there are 3 main challenges to be resolved. Reduce costs is going to happen because it will be printed. Plastic, graphene objects. The second one, the battery, has to be self-powering. The third, most important, that's a 5G challenge, it will be to get rid of the cable. That means make that connection there wireless so that they can finally move and perform any tasks we want them to perform. Cars is also a big issue. Maybe I just skip. So they have different type of requirements with respect to the other objects. The cars are basically the main challenge, opportunity is that there will be multiple interfaces, different type of technologies, but still the latency requirement, the reliability are all there. The trend in cars is not much to study the car as an application. It's going to be there. Already is there, very well studied. Autonomous driving is there. In Italy, University of Parma, in 2010, they had a car that moved from Parma to Shanghai autonomously as an app, using the sense of the car. No, we want to connect them. And we want to have a way to have, yes, autonomous driving or assisted driving, but network control, or network assisted at least. If we now look at the fourth technology I presented before, how the network may look like in the future, it is all SDN based, so it's completely separated the control from the forwarding layer. And we are expecting maximum 3 levels of control. We're expecting something residing into the devices, establish the connection, release that, and so forth. We are expecting then an edge controller that will be placed very near the end users in the infrastructure, but also it may be duplicated in the case where there is no coverage, so that you still maintain the communication among objects. And then we need an orchestrator controller. So we need an orchestrator which will make it possible to place the different functions and calculate the bandwidth need for each block to communicate each other for meeting the performance requirements. Okay. The network can be presented as an operating system, and the application, not only service application, but also the network functions can be installed easily on these two types of infrastructure so that you can realize any type of function. So the shifting paradigm, if you compare the future network to the current network, is that no longer will we talk about logical elements, mostly realized on a physical block. We talk about logical functions. So that depending on the customer requirements or the end user protocol establishment, I can realize my network, or even related to the business model. How to do this? We try to realize this and go into the dirty details and leverage the software-defined networking technology, SDN. Here I think we are talking about floodlights, doesn't matter, the open flow type of platform and a cloud computing platform. How could be realized and conceive the network in the future? It's just about handling applications over the 2 control layers I presented before. You will have an orchestrator where you will have 3 types of applications. One that will calculate and determine where the applications and the link bandwidth will be realized for establishing the control plane. And 2 enforcement model, the topology, like written here, topology manager for the application, the one for the links. Those will be located and spread across the different data centers. And then you do have an edge controller, which on top of which we can run any kind of functions from the cold connection management, mobility management, security, and radio access will be also handled as applications, orchestrated at the edge to meet the performance, admission control, and flow management. So our target is simply to unify the 4 fundamental functionality of the network of today, which are basically the security, the connectivity, the mobility, but we also would like to unify the routing management, which means to get rid of the tunneling protocols. We are now studying and implementing and testing this type of functionalities, and we got 2 questions from our customers. First questions. We have planning to invest a lot on LTE and its evolution. I mean, what are you doing now here? Everything changed? No, absolutely not. Those networks are just applications, so can run on our infrastructure. And here, we simply showed them how the control plane and the user plane, or LTE, latest releases could be supported by our architecture. They're just applications that could be easily realized and programmed across the network. Then the second question was, oh, the NFV all effort requirements, are you meeting them? Yes, we meet them. We just a matter of renaming terms and adopting the same type of terminology, and we presented them how we could do using the same concept as defined in the NFV manual architecture, establish both the control plane and the user plane. Why did we do all this? I remind that there are two fundamental requirements, new, brand new, crystal clear, new, that will drive the evolution of the network. One is the latency. If I don't meet the latency, I can connect only terminals, mobile phones. We want to connect cars, robots, drones, anything that moves and performs, does things for us. Latency, 1 millisecond, 5 to 1 milliseconds. And the second, the reliability. That's the architecture we conceived to achieve this goal. Now, does that perform? So what we did here, first, we analyzed the performance and end-to-end delay caused by the state-of-the-art technology when you establish a session, so you do an FTP. So you need to establish also the fault bearer. And then we compare the same type of procedure installed in our network, and we realized that we have a saving of about 70% in delay. We are currently implementing, analyzing that it's really, really performance with a real protocol to support the network. You see here the improvement we found are especially in the transition from an off state to a non-state. And that's characteristic of machines. You don't know never when there will be a transmitting data. There could be a lot of data, like a robot, maybe a drone that sent around to capture images, pictures, or it could be a small sense, just a little burst. So in this type of communication services, we found some adjustment in the always-on data plane. For instance, an SDN-based mobile core and an always-attached strategy that would dramatically improve the end-to-end latency of the network. Another question we get, yes, this is basically the logical architecture or logical function realization. How would the network would look like in practice if you really want to meet this performance end-to-end? And that is basically the last technology I wanted to discuss about. It's about networking. It has to be completely brand new. So we are expecting a new waveform at the radio interface, which I don't present today. And we are expecting also that the modulated and the digital signal transmitted across fiber. That will be both from backhauling, but also from front-hauling, if the layer 2, 3, and 4 processing, or even layer 1, is done at the edge, and not necessarily at the base station it's done today. All based on SDN, where it is programmable from layer 1 to upper layers, layer 3 at least. So that there is one way where we can efficiently provision the communication across the whole network and define and embed the proper spectrum, not only at the air interface, that we need to handle the whole spectrum from the cellular band down to centimeter, millimeter wave, but also across the fiber. Okay, that's basically, I have a couple of how much more time I have? Finished? 5 more minutes. Okay, maybe I do a couple of more slides. What we are trying to do now in Munich is the following. Yes, that's a big thinking. We need to put that in practice and see really that it works. And what we are trying to achieve now are 2 things. First, we will look at an indoor environment. And one of the targets could be like thinking of the aging population problem. We could think about realizing an aging, home-friendly environment so that we can connect, as you see here, different type of sensors. Even ICub, the robots can be used as sensors, actuators, like the other robot also coming from the IIT, that's University of Sant'Anna. and then integrate all these signals so that I can realize a true immersive experience for the person that will be in communication with the corresponding peer. It could be also an avatar, so that we have a simple way for everybody, including older people, to communicate, exchange information. That was going to be done indoor, and indoor we can push the signal at a very high speed using millimeter wave spectrum. And then we want to do the same type of exercise, but outdoor. So outdoor, we will implement the cellular bands, which means frequency below 6 gigahertz. And here, our target would be really to connect cars, to connect robots, and show our solution is truly meeting the two things, the two fundamental requirements, the latency and 100% reliability. It remains to be seen now whether we need a core network or not. I could have a breakout right away at the edge. But all of this needs to be studied. Like what needs to be studied is if you have many objects. If you look at ICub, it has 5,000 sensors. 5,000 sensors, theoretically, it's practically not true, but it could establish 5,000 connections. So what happens when all these things are moving from a place? Am I reconfiguring all tables? How the NFV platform will push the requirements into the SDN platform? Is that possible? So I think the network itself will be dramatically simplified. And that's what we are going to test and verify. If you look at the road mapping and when this technology will be in place, I think it's really aggressive, the time schedule. I've reported here the 5G PPP European Commission framework. Project were accepted recently, will be contractualized on July the 1st, and we start. We need to compare this with the standardization framework, which will be up and running already this year. So working items is going to happen this year, continue next year, and then, the study items, so use cases, functional architecture, and so forth. And then the network will be specified in details. So it's not that far in the future. 5G is coming and is going to be realized very rapidly. I can conclude basically that we believe the primary standardization framework will be 3GPP in support and liaison with the ONF represented this morning, IETF. A lot to say as well. We do need 5G tests and trials, and we are expecting large-scale tests in Europe. And we also welcome, of course, the contribution of the public party, not only at the European Commission level. I think we need to exploit properly the funds that the Commission made available at the country level, so at the member state level, so that all together we can realize this vision. So that basically concludes my talk. The slides are available, and you can download recent works we published. Thank you very much.